Hey everyone, in this video we will cover vocab from section 1.2 and a handful of example problems. Please go ahead and write the date that you're watching this video in the upper right hand corner. Be sure to take notes as you watch the video and remember to pause when you need to. So this video is going to cover segments and angles, and there's two important terms that have to do with both. So the first one is congruent, and so in geometry, congruent is our word for when we're talking about objects that are the same size and same shape. Our symbol for congruent, or the way we're going to our geometry notation for it, I should say, looks like an equal sign with a little squiggle above it. So that's our congruent symbol. The second word is bisect, and bisect means to cut in half. And there's no symbol for that. Usually we just use the word. So first, let's go ahead and talk about some vocab that has to do with segments. So first up, we know that a segment is really just a portion of a line that has two endpoints. So for instance, our segment here could have endpoints AB. Remember that we would call this segment AB with a small, tiny version of the object above it. So when we're talking about the measure of a segment, we're really talking about the distance between the two endpoints, or this is also called the length, okay? On a diagram, let's say that I still have my segment AB. Sometimes if we're actually talking about the numerical length of it, we would see like a little 4 right above it, okay? So this segment has length 4. We don't always have units. The notation for this, we're going to state what the endpoints are, A, B. I'm not going to put the line above it, and I'm going to say that it's equal to 4. Okay, so when there's no line above, it's talking about the measure. Next up is congruent segments. So congruent segments are segments that have the same length, and so this is talking about multiple different segments. So let's say that I have a segment AB. Let's say I have a segment, I don't know, let's call this one XY. Okay. If they're congruent, sometimes we will see a little measure above them that says, okay, 4, 4, I know that they're the same. More often, though, we are going to see them marked with a marking like this, okay? I like to personally call these tick marks. Some people call them other things, but the little lines tell us that they have the same measure, okay? And so we need to have these markings on the segments to know for sure that they are congruent. When we write out this statement that says that AB and XY are congruent, we're going to name each segment, so AB, XY, and then we're going to put our congruent symbol in between. Our next word is a segment bisector, and so a segment, remember, bisect means to split in half, okay? So think about in your mind, what do you think that means? It's telling you that it's going to be a point, a line, or a segment that splits a segment in half. So it's some sort of object that is doing the splitting. So what we could see, for instance, let's say I have some sort of segment AB, okay? And let's say that I have some sort of point. Remember, this could be a point, a line, a segment, something. And it's telling us that this segment is getting split in half, okay? So to show that it's getting split in half, we are going to have little tick marks on either side. Now, I should say that we can have however many tick marks we want. I could have 1 tick mark, I could have 2, but as long as they have the same tick marks, I know that they are congruent. So like, let's say for instance that this one has 2 and this one has 1. That doesn't mean that they're congruent because they're marked differently, okay? But anyways, for instance, in this case, we're gonna mark them the same. So this point here would be the bisector because it is doing the splitting. And there's no official notation for this. Our last word for segments is midpoint of a line segment, okay? And so think about what you think the word midpoint is. It is the point in the middle. Okay, and so for instance, in this diagram that we drew up here, this point is the midpoint because I know it is in the exact middle. But again, we need those tick marks to be able to know for sure. Okay. When you're ready, we're going to go ahead and flip over the page. If you need to pause the video and keep taking notes, go for it. Okay, so in this class, we're going to deal a lot with the measures of different geometric objects, so specifically segments and angles in this section. So the segment addition postulate basically just tells us how we can split apart different segments and their measures, okay? So I see here that I have a segment, I have an endpoint A and C, and then there's some sort of point B in the middle. In this case, just to kind of point it out, B is not the midpoint because I don't see any sort of markings on either side of it, okay? But the segment addition postulate tells us that if B is between A and C, then AB plus BC equals AC. So I'm going to go ahead and use a couple of colors to show this. So AB is this portion here, BC is this portion here, and AC is the whole thing. Okay, so what that's telling us is if I take the measure from A to B and I add it to the length between B and C, that's going to give me the length of the whole segment, okay? Flipping that around, if AB plus BC equals AC, then we have to know that B is in between A and C. So it's just kind of the converse of that. Okay, down below we have a couple of different example problems. We're not going to do them all, but I encourage you to try them. Let's go ahead and do A. Okay, so A is part of number 1, and it tells us that we want to find VW. So remember here we don't have a line above it, so it's asking us to find the length of the segment VW. So I see that VW is this length in between here. So a couple things I notice. I notice that 31 is the whole. Okay, that's the length of the whole segment. And 8 is just the length between W and U. So if I wanted to go ahead and find the length of VW, well, I'm just going to take the whole and I'm going to minus the part that I know. So I'm going to take 31 and I'm going to subtract 8, okay? You might be thinking to yourself, what's 31 minus 8? I personally think it's 23, so I'm going to say that VW is equal to 23. And if you disagree, please let me or your teacher know, okay? Couple other examples. I encourage you to try them, but we'll finish those together in class later. But sometimes the question can also not give us a diagram, which is no big deal. We just have to draw it ourselves. So here it tells us that points A, B, and C are collinear. Point B is between A and C, and we're going to find the indicated length. So first, I know that collinear here means that these are all on the same line. And it tells us that B is between A and C. So I have some sort of line. Here's points A and C, and I know that B is somewhere in between. So then let's go ahead and look at number 4. It tells us a couple of different lengths of this. So it tells us to find AC. So AC is the whole thing. That's what we want to know. If we know that AB, the distance between that is 16, and BC, the distance between that is 12. So in this case, we have 2 parts. And so if we want to find the whole, we just need to add them together. So 16 plus 12, you might be thinking to yourself, that's 28, and you're definitely right. So I'm going to write AC is equal to 28. Okay, we've done a couple of examples together. If you want to go ahead and try the other ones, you definitely can do so, but we will go through the rest of those in class. One last page we're going to do. All right, okay, let's talk about angles. So as a reminder, angles are 2 rays that share the same endpoint. So I'm going to draw myself a little picture. Let's name this angle, I don't know, BAC. So as a reminder, 2 ways that we can name angles. First, we can use 3 letters with the vertex being in the middle. So I could call this angle BAC, or I could also call this angle CAB. It doesn't really matter as long as that vertex A is in the middle. If the angle is all by itself, we can also name it just using the vertex, so angle A. So when we're talking about the measure of an angle, we're talking about how far apart the sides of the angle are. So I'm going to draw myself a picture. All right, so there's really 2 different types of angle measures we can have. We can measure on the inside of the angle. We can also measure the outer portion as well. In this class, we're mainly going to worry about the interior angle measure portion. So let's say that this angle measures 30. If I wanted to write out in geometry language that this angle measures 30, and as a reminder, we measure in degrees, and that's with the little bubble in the superscript. I'm going to name the angle BAC, and then to denote that I'm talking about the measure, I'm going to put an M out in front. So the measure of angle BAC is equal to 30 degrees. Or I can also just use the vertex. I can say the measure of angle A equals 30 degrees. Congruent angles are 2 angles that have the same measure. So maybe I have angle BAC, and then maybe I also have angle, let's call this maybe XYZ. So if these angles both measure the same thing, like let's say this was 30 and this was 30, we can show that on a diagram using the numbers. However, more often than not, we're actually not going to see numbers on a diagram. So to show that they're congruent, I'm going to put a little, what I like to call arcs, on our angles. Okay, and so these arcs, or sometimes I call them angle bands, are going to denote that these two angles are the same. Now, they have to have the same number of little bands on them. So if one has 1, but another has 2, that tells me that they measure 2 different things. So as long as they both have the same number of bands, I know they measure the same. Now, to write that these angles are congruent, I'm going to name them both. So angle BAC and angle XYZ. And I'm going to put that congruent symbol in between them. If I were using just the vertex, I would say angle A is congruent to angle Y. Okay, our next term is angle bisector. So remember, bisect means to split in half. So an angle bisector is a segment or array that is splitting an angle into two separate and equal pieces. So let's say that I have this angle here. Again, let's call this BAC. An angle bisector will connect to the vertex, and it will go out in this manner. Okay, and let's call this point D. So to show that this is an angle bisector, again, I want to show that each of these smaller angles is equal to each other. So we're going to put the congruent signs or the congruent little bands in the middle of there. Okay. And then there really isn't any notation for this. Okay, just like we had a segment addition postulate, we also have an angle addition postulate. This just tells us how we can add angles together. So reading this, it says that if B is in the interior of angle ADC, then the measure of angle ADC is equal to the measure of angle ADB plus the measure of angle BDC. So if I'm just going to highlight this, the measure of angle ADC looks like it's the whole angle. Excuse me. The measure of angle ADB is this portion here, and the measure of angle BDC is this angle here. So it's just saying that our small angle plus our small angle is equal to our big angle. All right, that is all for this video. We will complete the rest of these examples in class together, so I will see y'all later.